Hello students, the question says a non-uniform bar of weight W is suspended at rest by two strings of negligible weight as shown in figure. The angle made by the strings with the vertical are 36.9 degree and 53.1 degree respectively. The bar is 2 meter long. Calculate the distance d of the center of gravity of the bar from its left end. Here the word center of gravity is clearly given to us. In general in our syllabus, if nothing is mentioned, we'll assume center of gravity is equals to center of mass. If center of gravity is equals to center of mass, for this case, there is no need to solve this problem only because this d would be exactly half of this, which would be 1 meter. But remember, center of gravity is not always equal to center of mass. There are some scenarios where center of gravity will not be equal to center of mass. But since the other is giving that this is center of gravity, so we will take this point only as the center of gravity. This point as the center of gravity. Center of gravity in simple terms, I will not get into the details. It is where we will draw the net weight of the body. So here the net weight W is acting from the center of gravity. So here the weight of the bar is given as W. Now let us try to solve this problem. To solve the problem, we will draw free body diagram for the given case. So this is one rope. So let us assume the tension in this rope is T2. This is another rope. Let us assume the tension in this rope is T1. So we have T1 at an angle of 37 degree approximately. This I will take approximately 53 degree and we have W. Now let us resolve this T1 and T2 into components. So we'll take this bar and I will write here and we'll resolve this T1 and T2. So this is my T2. This is my T1. Here we got it as 1 at 36.9 degree. So if this is 36.9 degree, I will take approximately 37 degree. And this one, if this is 53 degree, we can write this one is also 53 degree and this one is also 53 degree, 37 degree. Once we know this, we will resolve this into two components. So I will resolve into horizontal component and vertical component. So the horizontal component would be, since this is tension T1, I call this T1 and we call this tension T2. So this component would be T1 sine 37 degree. Because it is opposite to 37, we can call it T1 sine 37 degree. I think by now you know vector resolution. So this one would become, the side to which theta is attached will be cos. So this one would become T1 cos 37 degree. Similarly, we can resolve T2 into components. So this one would be T2 cos 53. This one would be T2 sine 53. So this one would become T2 cos 53 degree and this one would become T2 sine 53 degree. And we have this W acting here. Since net force is 0, we can write T1 sine 37 degree in x direction. This is the equation in x direction. How did I say the net force is 0? In the question only it is given, like he has given that it is suspended and there is no movement also. So suspended at rest. So basically we can assume that the net force here is 0. So T1 sine 37 degree, left side force equals to right side force, T2 sine 53 degree. So we can write T1 into sine 35 degrees 3 by 5 equals to T2 into sine 53 degrees 4 by 5. So we can write 3T1 equals to 4T2. Let me call this as equation 1. Once we have this equation 1, we can write W equation also. Even though it is not that much necessary, we can write W equation as T1 cos 37 degree if I write equation in Y direction. So T1 cos 37 degree plus T2 cos 53 degree equals to W. So this is one more equation. Let me call this as equation 2. And the speciality of center of gravity is that net torque about that point So if I try to find the net torque, we will get 0. So let us try to find the net torque. Actually, net torque about center of gravity is equals to the total torque of all the small gravitational forces that is acting on the body. As I told you, if I start explaining center of gravity, this would become a lengthy video. So let us just try to find, since the body is in equilibrium. So equilibrium, we can take it as net torque is equals to 0. So I will try to find a net torque about this point, the point where this is acting, where the weight is acting. So I'll take this picture. Now let us write the torque equations. This is T2, this is T1. So if I resolve it into components, T1 cos 37, this one would be T2 cos 53, T2 sin 53, and this one would become T1 sin 37 degree, and this is the point where W is acting, and this distance is D. Let us write torque equation about this point exactly, from where the center of gravity is acting. Since we resolved into two components, it became very easy. We know, first let us find torque due to T1. Torque due to T1, T1 has two components. One is perpendicular component and parallel component. We know parallel components don't contribute to the torque. So due to T1 sin 37, the torque has 0 contribution. Due to T1 cos 37, the torque one is force into perpendicular distance. So the perpendicular distance is simply T. The total length in the question, it is given as 2 meters. If this is 2 meters, this one would become 2 minus T. And let us say whether this is clockwise or anti-clockwise. Suppose if you take, this is the point about which we are finding the torque, and this is the rod. If a force is applied in this way, we can clearly see that our rod rotates in clockwise direction. So due to this, we can say clockwise. But clockwise is not the direction of the torque. Direction of the torque would be inside. Clockwise will help us to identify, give it uh, a direction that would help us to easily identify what kind of torque acting. Like if this, when we say clockwise, it simply means that if you have a force in this way acting on this rod would try to move clockwise. That's what this clockwise is all about. Next, torque due to T2. So torque due to T2, again, we have T2 sin 53, T2 cos 53. This T2 sin 53 is along the line, along the rod, it won't contribute. Perpendicular to it, it would contribute. So torque 2 is T2 cos 53 degree into distance is 2 minus D. Now let us see how does this moves it. So this is my point, and we have our rod in this way, and we are applying force in this way. This moves it anti-clockwise. So it would be anti-clockwise. To explain you to detail, generally if one is clockwise, if net torque is 0, the other would be anti-clockwise. Then what about torque due to W? So torque due to weight W is 0. Why? Because the formula is force into perpendicular distance. This force is literally acting on that point. Since it is literally acting on the point, there is no perpendicular distance. So it would be 0. Now we will simply write clockwise torque equals to anti-clockwise torque equal to anti-clockwise torque. So based on that, our clockwise torque would become T1 cos 37 degree into D equals to T2 again cos 53 degree into 2 minus D. So T1 into cos 37 degree is 4 by 5 into D equals to T2 into this is cos 53 degrees 3 by 5 into 2 minus d. I will cancel these two. We got 4t1 divided by, let us bring this 3t2 also on the other side, equals to 2 minus d by d. So this is the final expression that we got. Let me call this as equation 3. If you look at equation 1, the equation is 3t1 equals to 4t2. I'll just place that equation here. So we have 3t1 equals to 4t2 as one equation. And based on this, what would t1 by t2 would become? T1 by t2 would become 4 by 3. So I can write this here. T1 by t2 is 4 by 3. We will get 4 by 3 into again another 4 by 3 is equals to 2 minus d by d. So we'll get 16 by 9 equals to 2 by d minus 1. So bring that 1 to the other side. 16 by 9 plus 1 equals to 2 by d. So it will become 16 plus 9 by 9 equals to 2 by d. So on solving, we will get d equals to 2 into 9 divided by 16 plus 9 is 25. So we got 2 into 9 by 25. So 18 by 25. This is the total length in meters. So the length of this is 18 by 25 meters. So in simple terms, we'll multiply with 4 in the numerator and 4 in the denominator. So this is 72 divided by 100 meters. So indirectly it is 0.72 meters. Here, as I told you, we have taken it as 50, 37 degree and 53 degree rather than 53.1 degree and others. And this is how we got the answer. As you can see, first we have here the center of gravity word is given. Generally, till now in the problems you have solved, center of gravity is taken as center of mass only, but there is a slight difference between them. I did not get into the difference part of this. We have drawn free body diagram. We have written the equation in x direction, which gave us the relation between T1 and T2. Y direction, it is not that much required, but just like that, we have written it. And then we have written torque equation due to each one. And after comparing all these things, we have got the value of D. So the distance is 0.72 meters from where the center of gravity is acting. Hope you understood how I have solved the problem.